In this MDX Tutors video, we're going to learn everything that you need to know about the algebra section for the GCSE. Let's start with simplifying expressions. Simplifying expressions is making an algebraic expression more efficient and compact. We usually do this by putting together like terms. But what are like terms? Well, this concept can be a bit complicated. Numbers, for example, are like terms, and so 3 and 8 can be put together with, for example, a sum. We can add 3 to 8 and get 11. Or we can maybe subtract 3 from 8 and get 5. Expressions with x are also like terms, so 2x and 5x are like terms. This means that we can do operations like 2x plus 5x, which gives us, we just put together the numbers 7 and then x. We can do 2x minus 5x. And in this case, 2 minus 5 is minus 3x. And there are many more operations that we can do this. The thing is that because 2x and 5x both have 1x, then they are like terms. We can also have expressions with variables. X, in this case, is also a variable, so it would be a specific case of this other example. Now we have two variables, a and b, and it doesn't matter the order in which these two variables are placed, because ab is the same as ba, because there is a product here. So 4ab and 9ba are also not like terms, and we can add them or subtract them like we did before. Numbers and variables, for example 8 and 3x, are not like terms. It is a very common error to do 8 plus 3x equal to 11x. This is wrong. We can only add 8 with 3 if they both have x, or if none of them have x, like in this case, or in this case. Whenever we have different indexes, are also not like terms, so we cannot operate x squared and x. That means that if I have x squared plus x, then there is nothing that I can do with this expression. There is no way that I can make it more efficient or more compact. And finally, when we have different variables are not like terms. So again, if we have, for example, 2x plus 3y, there is nothing that we can do with this. This is not the same as 5xy. This is not the same, this would be wrong. Let's have a look at this example. We have to simplify this expression. Let me write this expression again. The first thing that we're going to do is use the distributive law here. We have 3 multiplying all these parentheses, and so we can use the distributive law, which would give us the first two terms. We just leave them as they are because these two terms are not like terms, so 8x plus 4 is not an expression that we can make smaller. And so we have plus 3 times 2x minus, because of this minus here, 3 times 3. So now we have 8x plus 4 plus, here we have a multiplication, 3 times 2 is 6, and then we have x minus 3 times 3 is 9. So now we have to think which of these terms are like terms. Well, 4 and 9 are numbers, so we can operate between them. And then 8x and 6x both have only 1x. So 8 plus 6 is 14x. And then we will have minus 4 minus 9 is minus 5, so minus 5. And so this expression is equal to 14x minus 5. Let's have a look at this other exercise. Now we don't have any parentheses, so all we have to do is add together all those things that are like terms. Let's see what like terms we have. We have 3x squared, so a number accompanied by x squared, and here we have 2x squared with the same index in x, and so these two terms are like terms. So you have 3x squared plus 2x squared, that is equal to 5x squared. Next we have 5 minus 5 is a number, so we cannot put it together with minus 4x or with 7x, but we can with minus 1, which is also just a number. So minus 5 minus 1 is minus 6. Finally, we have minus 4x, so a number accompanied only by 1x, and 7x, another number accompanied by 1x. So minus 4x plus 7x, this is equal to plus 3x. And so this is the expression that we have. Now let's look at this other example. We have two parentheses multiplied by a number. So we have to use the distributive law. That is, we have to multiply 3 times 2x, 3 times 5, and then on this side 5 times x and 5 times minus 2. So let's do this. 3 times 2x plus 3 times 5. Then we have plus 5 times x minus 5 times 2. 3 times 2x is 6x. 3 times 5 is 15. 5 times x is 5x. And 5 times 2 is 10. So now we have an expression similar to the one we had before. And we have to look for like terms. 6x is like term with 5x. 6 plus 5 is 11. And so we have 11x. And then we have 15 and minus 10, two numbers. 15 minus 10 is plus 5. So this is the final expression that we have. Much more compact and simplified than the one that we started with. Now let's see substitution. Substitution means replacing the variables that are the letters in an expression with a numerical value. Doing substitution is very useful, for example, to calculate the area of a triangle or of any figure in general. Let's do this example. We have to find the value of 3b plus 4 when b is 10. So, because b is 10, all we have to do is put that value here. And remember that when we say 3b, we are saying 3 times b. And so this will be 3 times 10 plus 4. 3 times 10 is 30. And 30 plus 4 is 34. So the value of 3b plus 4 when b is 10 is 34. Now let's see this one. We have an expression that says that b is equal to 4k minus 10, and the value of k is 7. We have to work out the value of b. So if p is 4k minus 10 and k is 7, we have to put the value 7 where it says k. And again remember that 4k is 4 times 7. So p is going to be 4 times 7 minus 10. 4 times 7 is 28. And 28 minus 10 is 18. So the value of p when k is equal to 7 is 18. Now we have to work out the value of y when n equals 2 and d equals 5. So whatever it says n, we have to put the value 2. And whatever it says d, we have to put the value 5. Now we have that y is equal to 4 times 2, the value of n, minus 3 times 5, the value of d. 4 times 2 is 8, and 3 times 5 is 15. Now 8 minus 15 is minus 7. So when n equals 2 and d equals 5, y equals minus 7. Similarly, work out the value of 2x squared minus 3x when x equals minus 4. So let's do this. 2x squared minus 3x is going to be equal to 2 times, and when it says x, I have to put minus 4. So minus 4 squared, and then I have 3 times, and again minus 4 instead of x. This is 2 times minus 4 squared is 16, minus 3 times minus 4 is going to be a negative number. 3 times 4 is 12. So now we have 2 times 16. Minus and minus gives us plus 12. 2 times 16 is 32. And we have to add 12. So this gives us 32 plus 12 is 44. So the value of 2x squared minus 3x when x is equal to minus 4 is 44. Now let's see how we can change the subject of a formula. This is how to rearrange a formula to determine a missing quantity in terms of the others. It is the process that we apply every time we solve equations. And for this, we need to use inverse operations. These are the inverse operations. So, the inverse operation of the square is the square root. And the inverse operation of the square root is the square. The inverse operation of a division is a multiplication. And the inverse of a multiplication is division. And this happens for all of these operations that we have here. You have to memorize this table. Now we're asked to make f the subject of this equation. So we have that h is equal to f plus 4 divided by 2. So if we want to leave f alone, the first thing that we will have to do is remove the plus 2 on the denominator. Now because 2 is dividing f, then we will have to multiply by 2. So what we will do is multiply by 2 on both sides. Here it will just remove it. And here we have 2x. So the resulting formula after multiplying on both sides by 2 is 2h equal to f plus 4. And now we have this plus 4 that we want to get rid of. For this, we will subtract 4 on both terms. And here it's the same as saying minus 4 plus 2h. Now on the right hand side, this will cancel out. And here we will have, reaccommodating it, 2h minus 4 equal to f. Or what's the same, f is equal to 2h minus 4. And this way we have made f the subject of the formula. Now let's make x the subject of this other formula. 3x plus y equals zx minus 3z. So, because we have x on both sides, the idea will be to bring all of the x into one side. For this, let's take zx and move it to the other side. Remember that here you have a plus. And this will leave us with 3x plus y. Because we have a plus, we put it here with a minus zx. And then we have only minus 3z on this side. Don't forget about this minus sign. And now let's get rid of this y. Again, because it has a plus, we're going to move it to the other side with a minus. So this will leave us with 3x minus zx equal to minus 3z minus y. And now I have 3x and minus zx. So to add these two up, we can common factor x, and then we'll have 3 minus z. So I'm just removing the x from these two places and putting it in the front. So if now we had the distributive law, we would get back this expression. And on this other side, we don't need to do anything. So I have minus 3z minus y. But now because I want to make x the subject of the formula, and I have all this, that's multiplying x, then I can divide it. That's the inverse operation of the multiplication, and this will leave me with x equal to minus 3z minus y, and all of this will be divided by 3 minus z. And like this, we made x the subject of the formula. Now we have a bit more complicated exercise. We have y equal the square root of x plus 2 divided by x minus p. Because we have the square root on this side, we have to apply the opposite. We have to apply the inverse operation. And the inverse operation of the square root is the square. So we will have y squared equal to x plus 2 divided by x minus p. Now x minus p is dividing here, so I will have to multiply by it, and that will give me y squared times x minus p equal to x plus 2. And I want to have all the x on one side. So I will do the distributive law here, which will give me y squared x minus y squared p equal to x plus 2. Now let me just continue here. I have y squared x minus y squared p equal to x plus 2. Now here I have x, and here I have x. So let me just put all these x's together, and all of that does not have an x together. So I will have y squared x, and this one has a plus sign here. So I will have it with a subtraction is equal to 2. And because here I have minus sign, then I will add y squared b. Now, just like we did in our previous exercise, we common factor x and gives us y squared here minus 1. Because if I do the distributive law here, I will again get this. So this is equal to 2 plus y squared b. Now, because this term is multiplying x, then to actually make x the subject of the formula, I will have to divide all these other sides by y squared minus 1. And with this, we finished this exercise. Now let's see what is to expand brackets. This is something that we have already done. That is, multiplying the terms inside the brackets by the expression that is outside the brackets. And as we've seen, it's the reverse process of factorization. For example, if we have 2x plus 1, we have to multiply 2 times x and then add 2 plus 1. It's addition because here we have a plus. So this gives us 2x plus 2. Now let's work with this expression. Whenever we have 3 brackets multiplied, then we will first work with 2. And then, to that expression, we will multiply it by the third one. So to do this, we have to do the distributive law between these 2 brackets. That is, we start with x, and we multiply it by x, and by 4, and then we multiply plus 3 by x, and plus 3 times plus 4. So let's do that. X times x, then we have plus x times 4, and then we have plus 3 times x, and then plus 3 times plus 4, that is plus 3 times 4. And all this expression will be multiplied later by x plus 1. But let's focus on this expression. Let's focus on making it better. X times x is x squared. X times 4 is 4x. 3 times x is 3x. And 3 times 4 is 12. So now we can put together 4x and 3x. 4x plus 3x is 7x. And all this is multiplied by x plus 1. So now again we have 2 brackets. And we will have to do distributive law. So let's start with x squared. We will do x squared times x plus x squared times 1, that is x squared. Now 7x. 7x times x plus 7x times 1. Lastly, 12. 12 times x plus 12 times 1. And now we can make this expression better. x squared times x is x cubed. Then we have plus x squared. Then we have plus 7x times x is 7x squared. Then we have 7x. 12 times x is 12x. And finally 12. Now putting together like terms, the only ones we have are 7x and 12x, and x squared and 7x squared. So let's do this here. We have x to the power 3 plus 8x squared plus 19x plus 12. And that is what this expression is equal. Now let's solve this other exercise. We again are going to start only with 2x plus 3 and x minus 4. Let's do the distributive law a bit faster. 2x times x is 2x squared. 2x times minus 4 is minus 8x. And then we have the 3. 3 times x is 3x. And 3 times minus 4 is minus 12. And this expression we have minus 8x plus 3x. So that gives us 2x squared minus 5x minus 12. And I can grab this expression and multiply it by the last parenthesis. 2x squared times 3x squared is 6x cubed. 2x squared times minus 2 is minus 4x squared. Minus 5x times 3x is minus 15x squared. Minus 5x times minus 2 is plus 10x. Minus 12 times 3x is minus 36x. And minus 12 times minus 2 is 24. Now let's put the like terms together. So this one has no like terms. 6x cubed minus 4x squared minus 15x squared is equal to minus 19x squared. 10x minus 36x is minus 26x. And then we have plus 24. And this is the final expression. Now let's work on the difference of two squares. It's a method of factorizing used when an algebraic expression includes two square terms. This is the factorization, whenever we have one number squared minus another number squared. We can factorize it as a plus b times a minus b. For example, if we have x squared minus 9, what we realize is that 9 is actually 3 squared. And so in this case we have that a will be equal to x and b will be equal to 3. Remember that here we have a minus, but the same minus we have here. So b is 3 and not minus 3. Now using these values of a and b, we can substitute it in this formula and get x plus 3, that is a plus b, times x minus 3. In this example, we have x squared minus 100. And what we have to do is that 100 is 10 squared. So this is the same as saying x squared minus 10 squared. And so A will be equal to x and B will be equal to 10. So x squared minus 100 is equal to x minus 10 times x plus 10. And now we have this that looks a bit more complicated. But in fact we have to realize that in the denominator there is nothing that we can do. But in the denominator we can, because 16 is 4 squared. And so x squared minus 16 can be written as x minus 4 times x plus 4. And so we can write this expression as the same in the denominator, at least with the tools that we have so far. There is nothing we can do with this one. And instead of writing x squared minus 16, we can write x minus 4 times x plus 4. Now let's have a look at simultaneous equations. This is when we have two or more algebraic equations that share variables. Usually these variables will be x and y. We have to solve them simultaneously using elimination or substitution. Elimination is usually used when we have just one index, that is x to the power 1 and y to the power 1. But substitution is used when we have quadratic equations. So in this case, we'll use elimination. The idea of elimination is eliminating one of the variables. And we do this by multiplying one of the equations, or both of them, by some number, and then adding or subtracting them. So what we can do is try to eliminate the y variable. For this we have to multiply the first equation and the second equation by two numbers that could be different, and then add them together so that y doesn't exist. For example, if, let's call it equation 1 and equation 2, if we do equation 1 multiplied by 2, then what we get is 3 times 2 is 6x, then minus 5y times 2 is minus 10y, and then this would be equal to minus 31 times 2 is minus 62. And we can take the other one and multiply it by minus 5. This might seem a bit odd, but what we have is then 4x times minus 5 is minus 20x, minus 2y times minus 5 is, we get minus and minus, gives us plus. 2 times 5 is 10y, and 18 times 5 is 90. So now you can see that we have minus 10 in the first equation and plus 10 in the second equation. So all we have to do is add these two together. And this will give us 6x minus 20x. This is minus 14x. Now we have minus 10y plus 10y. This is 0y. And then minus 62 plus 90. This is 28. And so the equation we have is that minus 14x is equal to 28. And now we can divide by minus 14 and get x equal to minus 2. And so we found one variable. Now to find the second variable, all we have to do is substitute x into either one of these equations and then make y the subject of the formula to find its value. So let's do it with the second one. Now that x is equal to minus 2, we have 4 times minus 2 minus 2y equal to minus 18. 4 times minus 2 is minus 8. And so what we can do is get 2y equal to minus 18 plus 8 is minus 10. And then y will be equal to 5. If you want to check whether these two values are correct, then you can substitute them onto both equations. And then on the first equation you should get minus 31, and in the second equation you should get minus 18. And this one is a bit easier. Now we have x plus y equals to 6 and minus 3x plus y equals to 2. Let's call this equation 1 and 2. Now what we can do is multiply the second equation by minus 1 and add it to the first one. That way we will again remove the variable y. The first equation we will just leave it as it is, and we will do the second equation times minus 1. So this will change all the signs in this equation. Instead of minus 3x, we will get 3x. Instead of plus y, minus y. And instead of 2, minus 2. Now we can add them together. X plus 3x is 4x. Y minus y is 0y. And 6 minus 2 is 4. With this we have that 4x is equal to 4, and divided by 4 we have x equals to 1. Now we can substitute x equals 1 onto, for example, the first equation to get 1 instead of x plus y equal to 6. And so y is equal to 6 minus 1. That's 5. If you want to learn more about mathematics, you can check out our website or our Instagram and Facebook pages. Thank you for watching.